7.2, the angle properties of polygons. Plenty of regular questions have been done in the foundation course. You've got to look at them really. I'm jumping straight into the problem solving type questions. Question 12 is shown there. Penny fits together pentagons. They're regular pentagons. They're fitting together to make a circular arrangement. So if you look, we've got 1, 2, 3, 4, 5 pentagons. You go all the way around and just finish off back to the beginning again and make a nice little ringlet of pentagons. Part of the arrangement is shown just there. Show that exactly 10 pentagons, very important, 10 pentagons will fit together in this way before they meet up again and just join. So there's no guesswork here. I've got to calculate something quite special. Now let's think about this. Pentagon, we have an interior angle there and an interior angle there. If I can work out these two interior angles, I can find the remaining angle outside here, because of course it all adds up to 360. Now the blue angle, so to speak, is in fact the interior angle of what should be a 10-sided shape, a decagon. So what I'm going to do is first work out what that blue angle should be and then use my pentagons to see if I can arrive at the same answer. So let's just start as follows. I'm dealing with my decagon now. So I'm not going to say decagon equals, that doesn't make any sense at all. What I'm going to do is take 360 degrees, divide that by 10, and I will definitely get 36 degrees. And that, you may recall, is the exterior angle. Alright, because 360 degrees over the number of sides gives the exterior angle. So now I'm going to go the interior angle. That's the blue one. Well, it's on a straight line, so it's going to be 180, take away the 36 degrees, and that goes to me with 144 degrees interior angle. So I've proved that the interior angle of a decagon is in fact 144. Well, I haven't proved it, I've calculated it. Now if I can prove that these two yellow parts can give me an answer of 144 also doing it a different way, then I've proved that I've actually have a 10-sided shape, a decagon, being formed by these 10 pentagons. Very interesting. So now I'm going to talk about pentagon here. In other words, one of these orange things. Same trick again. I'm going to take 360 degrees, divide that by 5. I will get 72 degrees, and that is my exterior angle. No problem. So if I can work out one of these little yellow ones here, that'll be my interior angle. So that's my next step. And of course that's going to be 180, take away the 72, and that will give me 108 degrees. And that's that. Don't need to write down interior angle again, do we? That's that. So now that's that. Now if this is 108, I'm going to write it down here. This will also be 108 because it's a regular pentagon. So I'm now going to say to myself, well, I've got two lots of 108 degrees, and that's going to give me 216 degrees. Now the blue angle is going to be 360 degrees, take away 216 degrees, which is in fact all 144 degrees. Is that alright? So don't need to use any more words. Therefore, this is the interior angle of a regular decagon. Therefore, 10-sided shape. Is that right, my dears? So I've proven initially, well, I've calculated initially this blue angle is 144. Just write it in there. And just to set the scene, and then I've worked using the pentagons to work out the two interior angles of each pentagon. 108 each comes to, just revising now, 216, both of them. Subtract from 360 because that forms angles as a point and up to 360. I've proved that the interior angle of this decagon was 144, and that matches the 144 I calculated earlier. Therefore, we've got the question right, and we've proved it very convincingly. And that's what it takes at the higher level to do this sort of thing. Now I'll do question 13 and then stop, and it says one of these problem solving things again. A company makes containers as shown, very pretty. The top is the shape of a regular octagon, so look at 8-sided shape, put a little 8 there. What is the size of each interior angle? Well, it's not very difficult. That's going to be, let's just work in yellow down here. I've got exterior angle first. Let's do that. That's the normal way. It's going to be 360 over 8. Grab my machine quickly because I'm a chicken. I think it's 45. Anyway, 360 divided by 8, 45 degrees. Well, that's the angle on the outside. So the interior angle, as you know, is going to be 180, because angles on a straight line add up to 180. Take away the 45, the exterior angle, and that's going to give you 135, and that's your interior angle. So if you like, each of these are 135. It doesn't look like it because of the way we have the perspective on the top, but essentially each of those exterior angles is 135 degrees, so we've got that. It's completely correct. When the company packs them into a box, will they tessellate? Now remember, tessellation is formed when shapes fit together in such a way that they leave no gaps at all. Okay, so essentially I'm looking at something like this. Here's an 8-sided shape. 1, 2, 3, 4, 4, 5, 6, 7, 8. Very crude. Will I get another 8 to fit perfectly there? Don't know yet. Essentially, will the angles here at this point where the octagons meet form 360 degrees? Well, I know the interior angle is 135 degrees. I know this interior angle is 135. Now, so far I have 270 degrees. 3 lots of 135 equals, what's that? Calculator quickly. 135 times 3 gives me 405 degrees, which is greater than 360, and 2 lots of 135 doesn't quite make it, does it? It only comes to 270 degrees. Therefore, will not tessellate, because the angles will not form 360 degrees at a point. How's that? Will not form 360 degrees at a point, and of course the point is right there. 2 is too little, 3 is too much, so they won't tessellate. And if not, well, there's the hint there, it was never going to tessellate. If not, what shape will be left between these octagons? Well, if I've got 270 degrees and these two shapes meet at a point, I've got essentially, this is part B now, I'll work over here, I've got 360 degrees, take away my 2 lots of 135. So what does that mean? That's going to give me 360, take away 270, that leaves me 90 degrees. Therefore, what shape is going to be left in the middle of them to make up the difference? It's going to be a square. So if you imagine here, and I'll try and make it fit not too terribly, I've essentially have a square. Now if I have 2 octagons placed like so, what's left over is a square, and up here will also be, you know, a square, etc. So I can build up a tessellation of regular octagons with squares fitted in the gaps to make 360 about each point. So that's that question done, and that really is the end of section 7. I'll take the majority of my questions from the assess. That's where some of the interesting questions really are, but that's going to stop right now, and that's fine.